A rectangular loop has 85 turns with an area of 0.225 meters squared and lies in a uniform magnetic field of 0.38 teslas. Several physics lab students have reported that the maximum torque exerted on the loop is 1.2 times 10 to the minus second Newton meter. First question is, what is the current in the coil? Second, if instead all 85 turns are unwound and form a rectangle with the same shape, but obviously much larger, would the value of current be larger, smaller, the same? And then calculate the value of the current in this case to confirm your answer above. Okay, so first of all, this is the torque on the current loop in external magnetic field. So this is the torque, this is the magnetic moment, I think. Let me check. Yes, that is magnetic moment. So you have surface area, you have current, and that is the magnetic moment. Very nice. So magnetic moment is, this is the current, this is the area of that loop, and N is AN, and N is number of the loops. Okay, so current from this equation is equal to this torque divided by all of this here. This is the area of one current loop, this is the number of the things, and this is the external magnetic field. So we have everything: torque, area, number of the loops, and that is actually magnetic induction. So magnetic field, and we get to be 2.34 times 10 to the minus 3 amperes. That is the current within that current loop. Okay, now if instead of 85 turns we unwound all those wire and make just one loop, what will happen? So here we have 85 times 4 times A. So this is the A is side of that square, of that smaller square, and we have 85 of those, and we want to build just one from all of this. So that is 4 times B, and B is from here 85 times larger than A. We have that the smaller, what is the meaning the smaller? Okay, so B squared is when you square both of these sides, and we have this to be B squared and this to be 625 watt meter squared. Here, or in other words, 80B squared is 85A squared, and we already had this in previous assignment, that to be AN. And that's, and I didn't want to show you this, but what can you do? So it doesn't matter, current is 85 times smaller. Why? Because this B squared here this B squared here is actually, as you can see, 80 times AN, and that is why is that. So I hope you understood what I'm trying to tell you. Now maybe only this is something that is making problems, so let me draw you here. So we have one current loop, and this is A, this is A, and we have 85 of those. That wire go around and 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 around 85 times, and we unwind that wire and have one large wire loop. So we have B here and B here. So this is A, that would be much smaller than B and B. So from all of this wire, 85 of these small loops, we just create one large one. So everything is here. There is nothing more in the assignment. There's nothing more in PDF file except this. I show you everything. but if you want to donate, you can do that. And if you want to download this, you can. For complete written assignment, please follow the link in the description. If you want more of this, please subscribe and tell your friends. Thank you. Bye.